think of E equals mc squared, we have this vision of Einstein as an old, wrinkly man with white hair.
E equals mc squared is not about an old Einstein. It's actually about a young, energetic, dynamic, even a sexy Einstein.
What would I see if I rode on a beam of light?
Perhaps some sort of electrical force is emanating outwards from the wire.
What? Faraday, my dear boy, electricity flows through a wire, not sideways to it.
You see, John? You see?
It is my great ambition to demonstrate that nature is a closed system, that in any transformation, no amount of matter, no mass, is ever lost and none is gained.
The people. It is they who will determine right and wrong.
Emily, you are being absurd. Why ascribe to an object a vague and immeasurable force like vis viva? It is a return to the old ways.
Are you capable of discovering something of your own?
I discovered you!
There is no right time for the truth.
Fräulein Meitner.
Yes?
Otto Hahn.
The nucleus is our focus.
The U.S. endangers our institute.
We can't harbor a Jew. If she stays, the regime will shut us all down.
Is split the atom.
No. You've split the atom.
Energy equals mass times the square of the speed of light.
Would you like me to check your mathematics?
Hace 100 años, una fórmula engañosamente simple reveló una unidad oculta, enterrada en las profundidades de la estructura del universo. Nos habla de una conexión fantástica entre la energía, la materia y la luz. Su autor fue el joven Albert Einstein. Se trata de la ecuación más famosa del mundo. E es igual a m por c al cuadrado. Pero mientras que todos hemos oído sobre la gran idea de Einstein, muy pocos saben lo que significa. De hecho, E es igual a m por c al cuadrado es tan extraordinaria que incluso Einstein no estaba seguro de que fuera verdad.
Albert, darling, you're later than I expected. We've only got sausage and cheese tonight. What is it?
We need to talk.
Has something happened?
Oh, no, nothing. Sorry, no. I spent most of the day staring out the window at work, looking at trains. And I started to think about an object and how much energy it had. Can I explain it to you?
Of course you can. But first, dinner, food and talk.
I think the gods are laughing at me.
Los dioses no se reían de Einstein. Había unificado con una impresionante perspicacia el trabajo de muchos antes que él. Científicos que habían luchado e incluso muerto para crear cada parte de la ecuación. La historia de E igual a m por c al cuadrado comenzó mucho antes de Einstein, con el descubrimiento de la E de energía. A principios del siglo XIX, los científicos no pensaban en términos de energía, pensaban en términos de potencias o fuerzas individuales. Todas estas eran cosas desconectadas, sin relación entre sí. La potencia del viento, la fuerza de una puerta que se cierra o el estruendo de un rayo. La idea de que hubiera algún tipo de energía que abarcara y unificara detrás de todas estas fuerzas aún debía revelarse. El interés de un hombre modesto por entender los misterios ocultos de la naturaleza comenzaría a cambiar todo esto.
Young Michael Faraday hated his job. He was uneducated, the son of a blacksmith. He'd been lucky to become a bookbinder's apprentice. But Faraday craved one thing. He craved knowledge. He read every book that passed through his hands. He developed a passion for science. All of his free time and his meager wages were poured into his self-education. He was on the threshold of an incredible journey into the invisible world of energy.
Faraday había impresionado a uno de los clientes de su maestro y fue recompensado con un boleto que le cambiaría la vida.
Excuse me, please. Can I pass, please?
Can I pass?
Some of us are trying to improve ourselves. If people will let us.
Of course. Pass. This way to a better life.
In the early 1800s, science was a pursuit of gentlemen, something Faraday was clearly not. He had a rudimentary education, he'd read widely, he'd gone to public lectures. But in 1812, he was given tickets to hear Sir Humphrey Davy, the most prominent chemist of the age.
Los científicos del siglo XIX eran las estrellas pop de la época. Sus conferencias eran muy populares. Era difícil conseguir un boleto y Davy se regodeaba con su estatus.
They're waiting.
I know.
Era también un entusiasta seguidor de la última moda, el óxido nitroso o gas hilarante. Decía que tenía todos los beneficios del alcohol, pero sin la resaca.
Electricity, ladies and gentlemen. A mysterious force that can unravel the confusing mixture of intermingled substances that surround us and produce pure elements.
Davy was an absolutely first-rate scientist. However, many will come to say that his greatest discovery is Michael Faraday.
Metals unknown, that is, until I isolated potassium from molten potash and sodium, as I showed you last time, from common salt. That same magical
Quizá Faraday no había nacido caballero, pero no iba a permitir que las barreras sociales le impidieran seguir una carrera en las ciencias. Trabajaba sin descanso por las noches para unir sus notas de las conferencias en un libro para su nuevo héroe.
Lord, help me to think only of others, to be of use to mankind. Help me be part of the great circle that is your work and love. Lord, I am your servant.
Well, this is excellent work, Faraday. So what is it you aim to do with your life?
My desire, sir, is to escape from trade, which I find vicious and selfish, and to become a servant of science, which I imagine makes its pursuers amiable and liberal.
Really? Well, I shall leave it to the experience of a few years to set you right on that score. Look, I haven't anything at the moment. I'll send a note if anything comes up.
Pese a este humillante revés, Faraday estaba decidido a liberarse de sus faenas diarias. Su paciencia se vio recompensada.
Newman, meet Mr. Michael Faraday. He's going to be my helper while I recover. He assures me he is a Christian fellow. Perhaps with God and Faraday in charge of the chemicals, you and I will be safe in our place of work.
Thank you, Professor Davy. Welcome, Faraday.
Oh, no, thank you, and thank you, Sir Humphrey.
Just stick to your job and do as you're told, and you'll be fine, Faraday.
Faraday se convirtió en asistente de laboratorio y absorbía con avidez cualquier migaja de conocimiento que Davy se dignara a impartir. Pero con el tiempo el alumno superaría al maestro. La sensación de la época era la electricidad.
Another charge, Newman.
Acababan de inventar la batería y se realizaban todo tipo de experimentos. Pero nadie entendía realmente qué era esta extraña fuerza de la electricidad.
The academic establishment at the time thought that electricity was, like a fluid flowing through a pipe, pushing its way along. But in 1821, a Danish researcher showed that when you pass an electrical current through a wire and place a compass near it, it deflected the needle at right angles.
Esta era la primera vez que los investigadores veían que la electricidad afectaba a un imán. Fue el primer atisbo de dos fuerzas que se habían considerado totalmente separadas. Ahora se unificaban de forma inexplicable.
Faraday, come look at this. You're the bright spark around here. Perhaps you can work it out. Ersted's reported an amazing finding. We're just replicating it here.
Let's try the compass on the other side.
Now that is remarkable.
But if the electrical force is flowing through the wire, why does the needle not move in the same direction, parallel to the wire?
Quite.
Let's try turning the whole apparatus round.
Again, Newman.
So, the electrical force goes this way. The compass points that way. How can one affect the other?
Perhaps the electricity is throwing out some invisible force as it moves along.
What?
Perhaps some sort of electrical force is emanating outwards from the wire.
Oh, my dear boy, let me tell you that at the University of Cambridge, electricity flows through a wire, not sideways to it.
Well, that may be what they teach at Cambridge, but it doesn't explain what's happening before our eyes.
No, let's just get on. Let's swap the compass to below the wire.
El por qué la brújula se desviaba en ángulos rectos y por qué la electricidad afectaba la brújula tenía pasmados a Davy y a muchos otros.
As we celebrate the marriage of Michael and Sarah.
Para Faraday, sin embargo, el problema se convirtió en una obsesión. Era una fascinación inspirada por su religión. Para él, el problema era una forma de entender los misterios del Señor.
There was a small, almost persecuted group in London called the Sandemanians. They were religious, not really a sect. They were just a small subset, sort of like Quakers. Faraday was a member of that group. It was a very gentle, decent group. They believed that underneath the whole surface of reality, everything was created by God in a unified way, that if you opened up one little part of it, you could see how everything was connected.
Michael Faraday was someone who, like Einstein, thought in terms of pictures.
Faraday was different from anybody else. He had a flair for understanding his experiments, for understanding what was really going on inside them.
Al colocar metódicamente una brújula por todo el derredor de un alambre electrificado, Faraday comenzó a notar una pauta.
What everyone else at the time had been taught was that forces travel in straight lines. Faraday was different. Faraday imagined that invisible lines of force flowed around an electric wire. And then he imagined that a magnet had similar lines emerging from it, and that those lines would get caught up in this flow. It was a bit like a flag in the wind.
Pero el gran salto imaginativo de Faraday fue cambiar este experimento en su cabeza. En vez de que un cable eléctrico moviera la aguja de una brújula, se preguntó si lograría que un imán permanente moviera un cable.
I've never seen you like this, Faraday. You look like a happy child.
I'm shaking, Newman. Underneath, I'm shaking. You see, John? You see? Yes.
This is the experiment of the century. It's the invention of the electric motor. Scale up the magnets and the wires, make them really big. Attach heavy weights to them, and they'll be dragged along. But almost more importantly, he's inventing a new kind of physics here.
Aunque no se dio cuenta en su momento, Faraday acababa de demostrar un principio fundamental. Los químicos de la batería se habían transformado en electricidad en el cable, que se había combinado con el imán para producir movimiento. Detrás de todas estas fuerzas distintas había algo en común: energía.
A couple of months earlier, Davy had been elected president of the Royal Society, which was the elite body of English science. But then he saw this great discovery published in the Quarterly Journal of Science. I don't know if he was envious, but he certainly saw that this young man who had been his assistant, this mere blacksmith's son, had come up with one of the greatest discoveries of the Victorian era.
Davy accuses Faraday of plagiarizing similar work from another eminent British scientist, William Wollaston.
So, Faraday, what does Wollaston make of all this?
He's written to me and assures me that he's taken no offense. And he acknowledges that what I published was entirely my own work.
Right. Davy is just being an ass.
But will Davy now retract his allegation?
Sadly, no. In fact, he's still vehemently opposed to you being elected a member of the Society.
Really? And what do you think?
Faraday, my dear boy, you have my vote.
And mine. And I believe you even have Wollaston's.
Oh, what a mess.
Well, no matter. It's the science that counts. So tell me, how does this wire of yours spin round its magnet? What mysterious forces are at play?
There seems to be an electromagnetic interaction. In my mind, I see a swirling array of lines of force spinning out of the electrified wire, like a spiraling web.
But invisible lines of force, it's all a bit vague, isn't it?
Faraday, might I have a word in private?
Certainly.
Listen, Faraday, let's stop this nonsense. I want you to take down your ballot paper from the notice board.
Sir Humphrey, I see no reason to take it down. My friends have proposed me. It is they who put the paper up. I will not take it down. Good day.
Faraday fue elegido miembro de la Real Sociedad. Davy murió 5 años después, víctima de sus muchas inhalaciones gaseosas. Con el tiempo, el mundo de fuerzas invisibles de Faraday traería toda una nueva forma de entender la energía. Había comenzado lo que Einstein llamó la gran revolución. En el corazón mismo de este nuevo y excitante mundo de energía, creció Einstein.
My father and uncle wanted to make their fortune by bringing electric light to the streets of Germany. From an early age, I loved to look at machines, understand how things work.
He's going to kill himself. Albert, stay there.
I experienced a miracle when my father showed me a compass. I trembled and grew cold. There had to be something behind objects that lay deeply hidden. At high school, they had their ideas about what I should learn. I had my own.
Einstein.
I was merely interested in physics, maths, philosophy, and playing the violin. Everything else was a bore.
Einstein! On your feet! As you obviously know everything about geology, tell me, how does a rock start run here?
It's pretty much the same to me whichever way they run, Herr Professor.
Los maestros de Einstein trataban de hacerlo entrar en razón mientras Faraday demostraba que la energía podía convertirse de una forma a otra. También se creía que ya se habían descubierto todas las formas de energía. Einstein iba a demostrar que se equivocaban, pues descubriría una nueva y vasta reserva de energía oculta donde a ningún otro científico se le había ocurrido buscar, en lo profundo del corazón de la materia. 100 años antes del nacimiento de Einstein, el rey Luis XV ocupaba el trono de Francia. Pero el antiguo poder absoluto de la monarquía sobre el pueblo comenzaría a desafiarse.
Jacques, leave the windows. Forget the rain. We need air.
La Revolución Francesa estaba a la vuelta de la esquina.
This was the era of enlightenment, when intellectuals believed very firmly that the way forward lay in science. And they felt that one of the first tasks that lay ahead of them was to rationalize and to classify every single kind of matter so they could see how it all interacted together.
Antoine Lavoisier, un joven aristócrata rico, decidió asumir esta tarea para ver si había alguna conexión básica entre todas las cosas de la vida diaria, todas las sustancias distintas en el mundo. Pero lo que como científico funcionaba para Lavoisier, su meticulosa y casi obsesiva atención al detalle, habría también de ser su perdición.
Monsieur Lavoisier, you are, if my eyes do not deceive me, consuming only milk this evening. First you had a glass of milk, now you are eating a bowl of milk. Will you next move on to a plate of milk?
Your precise observations commend you as a lady of scientific curiosity, mademoiselle. Most unusual. As you seek knowledge, so I shall dispense it. For the last 5 weeks, I have taken nothing but milk.
Good God, man. I would rather die than fast on milk for 5 weeks. Are you in the grip of some horrendous ailment?
On the contrary, I am investigating the effects of diet on health.
Monsieur, with the greatest of respect to a member of the Royal Academy of Sciences, your gut must think your throat has been slit.
Whereas your gut, Count, is no doubt petitioning the Academy for a widening of your throat.
Marianne, how dare you insult the Count? forget what the Count offers. Not just marriage, but think of how you will be introduced to all the salon. You will be the toast of Paris.
Would it not be a shame, madame, to burden you with the duties of matrimony before you have had a chance to experience your curiosity for nature?
Shall we all go through? It's getting rather hot in here.
You really plan to marry the Amava?
There is a plan, but it is not mine.
Then I must contrive to save you.
Lavoisier no era científico de profesión, era el jefe de recaudación de impuestos en París. Su gran idea fue construir un enorme muro alrededor de la ciudad y cobrar un impuesto por todo lo que entraba y salía. Pero sus impuestos sobre las cosas sencillas de la vida, pan, vino, queso, no lo hicieron muy popular entre la gente común. El joven escrupuloso y maniático, sin embargo, se permitía algún acto de pasión ocasional. En 1771, Lavoisier se casó con Marianne Pauls, la hija de su colega en la oficina de impuestos, salvándola así, como lo había prometido, de un matrimonio arreglado con un conde 40 años mayor que ella.
Allow me to show you something.
Lavoisier, I think, found his job as a tax collector really rather tedious, and the times he looked forward to were the evenings and the weekends when he could indulge his passion for chemical experimentation. And he called those times his jours de bonheur, his days of happiness.
Madame. What will happen if I take a bar of copper or iron and leave it outside in the rain for months on end? Madame Lavoisier.
Monsieur Lavoisier.
The metals. What will become of them?
Is this a verbal examination? Prior to an examination proper, sir?
I merely seek the truth.
Then you toy with me, monsieur, for you know the truth. The copper will become covered in a green verdigris, and the iron will rust. I believe the term is calcined.
Most impressive, my charming wife. But let me press you further. When the metal rusts, does it get heavier or lighter?
Why, sir, I think you mean to trap me.
Oh. Then perhaps this little butterfly should land and allow me to take a closer look.
Every last citizen in France of sensible age knows that when a metal rusts, it wastes away. It gets lighter and eventually disappears. Stop. I have not finished. Contain yourself, sir. There is more. In a recently published pamphlet by a brilliant young chemist, Antoine Lavoisier demonstrates that the iron combines with the air. It, in fact, becomes heavier.
Most impressive. I intend...
Now, whatever you intend, monsieur, I intend to be by your side. I will learn all I can about your science and become your worthy colleague.
Then let me show you how the iron combines with the air to form such a delicate union.
Tomorrow, monsieur. Tomorrow.
Marianne aprendió química junto a su esposo, pero muy pronto buscó otras formas de contribuir a su trabajo. Aprendió inglés para traducir obras científicas contemporáneas. Tomó clases de dibujo para poder registrar con detalle forense las minucias de su trabajo juntos. Dirigía el laboratorio y era la cara pública de Lavoisier, sociedad anónima. era capital en todo este esfuerzo de investigación.
That is a terrible thing to say. You are a cheeky man.
This way, please, gentlemen. Monsieur, it is my great ambition to demonstrate that nature is a closed system. That in any transformation, no amount of matter, no mass, is ever lost and none is gained. Over here, please. This precise amount of water is heated to steam. This steam is brought into contact with a red-hot iron barrel embedded in the coals. From this end, we cool the steam. But interestingly, we collect less water than we started with. So clearly, we lose a certain amount of water. However, we also collect a gas, and the weight of the iron barrel increases. Now, when we combine these two increases, the new weight of the iron barrel and the gas we have collected, they are exactly equal to the weight of the lost water.
Ah, but is it atmospheric air, Monsieur Lavoisier?
No. No, because I am measuring it to the very last grain. I can see that it is lighter than the air around us, and moreover, it is flammable. Voila.
Water is made out of hydrogen and oxygen. So what he had done is get the oxygen to stick to the inside of a red-hot iron rifle barrel. He was basically just making rust, which is oxygen and iron, but he was making the rust really quickly. Now that left the hydrogen, what he called combustible air, and that was just floating around as a gas. No mass had been lost, it had merely been transformed. And now he wanted to transform it all back into water.
This is only the beginning. In the next few months, I hope to demonstrate that I can recombine this combustible air with vital air and transform them both back into water. I will recreate exactly the same amount of water that was lost here in this process. It is my hope to complete the cycle, water into gas, into water, and not a drop lost.
For a long time, Lavoisier had suspected that the exact amount of matter, the mass, involved in any transformation was always conserved. But to prove this, he had to perform thousands of experiments, and he had to do the measurements with incredible accuracy. That's where his great wealth from being a tax collector came in. He could afford to commission the most sensitive instruments ever built. He became obsessed with accuracy.
Pero los métodos exactos de Lavoisier comenzaban a enfurecer a una creciente muchedumbre de parisinos hambrientos y decepcionados.
Antoine? Antoine? Oh, wake up, Antoine!
I'm sorry. What time is it?
This is almost time to receive Monsieur Marat. The Academy asks you to assess his designs. He claims to have made a great discovery. Oh, Antoine, have you forgotten?
Oh, God. There's another charlatan with an idea to peddle. God give me patience. Monsieur Marat.
Monsieur, I have invented a device which projects an image of the substance of fire onto a screen. You see? When a lantern is shone through a flame, we see a shimmering pattern above the flame. My device renders the substance of fire visible.
Have you collected it, this substance of fire? Have you trapped it and measured it?
Oh, no, but one can see it.
I'm sorry, in the absence of exact measurements, of precise observations, without rigorous reasoning, one can only be engaging in conjecture, so this is not science.
I am not given to conjecture, monsieur.
Really, no. If you will excuse me, I am extremely busy today, but thank you. Thank you.
So that is all? Then good day, monsieur!
Let me guess, Marat. The King's scientific despot has decreed that your invention does not conform to the version of the truth as laid down by the Academy.
Lavoisier. He talks about facts. He worships the truth.
Listen to me, my friend. They are all the same, the Royal Academies. They insult the liberty of the mind.
They think they are the sole arbiters of genius. They are rotten to the core, just like every other tentacle of the king. The people. It is they who will determine right and wrong.
Don't worry. In my next pamphlet, I will expose this persecutor of yours.
Durante años, los Lavoisier quemaron, cortaron, fundieron e hirvieron cualquier sustancia concebible. Habían demostrado que mientras se fuera escrupuloso al recolectar los vapores, líquidos y polvos creados en una transformación, la masa no mermaba. Los líquidos podían convertirse en gases, los metales podían oxidarse, la madera terminar como humo y cenizas, pero de la materia, los diminutos átomos que conforman todas las sustancias, no se perdía nada. La gloria máxima de esta obra fue su notable uso de la electricidad estática para hacer que el oxígeno y el hidrógeno volvieran a combinarse en agua.
What is happening?
Cuando estalló la Revolución Francesa, la familia real y un gran número de aristócratas perdieron la cabeza en la guillotina.
To the French revolutionaries of 1790, Lavoisier meant one thing and one thing only. He was the despised tax collector who'd built that wall around Paris.
El trabajo de Lavoisier como recaudador de impuestos lo puso bajo sospecha. Lo denunció un fallido científico convertido en periodista radical, Jean-Paul Marat.
Où est Lavoisier?
Je sais pas.
Lavoisier! Lavoisier! Lavoisier!
What Lavoisier did is absolutely central to science and especially T equals mc squared. Because what he said is if you take a bunch of matter, you can break it apart, you can recombine it, you can do anything to it, and the stuff of the matter won't go away. If the mob burned Paris to the ground, utterly razed it, shattered the bricks into rubble and dust, and burned the buildings into ashes and smoke, turns out if you put a huge dome over Paris and weighed all the smoke and all the ashes and all the rubble, it would add up to the exact same weight as the original city and the air around it before. Nothing disappears.
Un siglo después, toda la naturaleza había sido clasificada en dos grandes reinos. La energía, las fuerzas que animaban los objetos, y la masa, la sustancia física que conformaba dichos objetos. La ciencia del siglo XIX se basaba en estos dos poderosos pilares. Las leyes que gobernaban a una no aplicaban a la otra. Pero al joven recién ingresado a la carrera de física, Albert Einstein, no le gustaban las leyes.
Good grief, Einstein. What happened to you?
It is more than a little ironic, having been reprimanded yesterday by that idiot Professor Pernet for poor attendance, that I should in fact attend a practical lesson, which was as long as it was boring and utterly pointless, by the way, only to be the victim of an explosion of my own apparatus.
So it was your own fault then?
Thank you. And how are you today, Fraulein Manage?
Extremely well, Herr Einstein. All the better for seeing you have escaped the physics laboratory with your life.
Well, in order not to alarm you any further, I pledge to forever continue my studies here at the Café Bahnhof, reading only the great masters of theoretical physics and eschewing the babbling nonsense of the polytechnicians.
It's about all you ever do.
It's getting a little stuffy in here, Fraulein Marriage. Would you care to take a walk with me? There's something I'd like to discuss with you.
Why, Herr Einstein? Of course. Perhaps you'd like me to tell you what you have missed in lectures this week.
Einstein wasn't exactly a model student. He excelled in certain subjects, especially physics and math, but he wasn't very diligent in a lot of his other classes. He was undoubtedly very questioning, which seems to have annoyed most of his professors throughout his life. He would pursue his fascinations with just incredible determination.
We know from his letters that Einstein, even from the age of 16, was literally obsessed with the nature of light. Everyone he could speak to, his friends, his colleagues, even his then girlfriend, Mileva Merrick, who would become his wife, everyone he badgered with the question, what is light?
What would I see if I rode on a beam of light?
What? A beam of light? By what method do you propose to ride on this beam of light?
The method is not important. Let us just imagine me two are young, radical, bohemian experimenters, hand in hand on a journey to the outer reaches of the universe, and we are riding on the front of a wave of light.
I really don't know what you are suggesting, Herr Einstein. Do you wish to hold my hand or ridicule me?
Ridicule you? No, never.
I merely want you to help me to understand. What would we see, do you think, if we were together and we sped up and up until we caught up to the front of a beam of light?
La incansable búsqueda de la luz de Einstein lo llevaría a revolucionar la ciencia. Con la luz reinventaría el universo y descubriría la vía oculta que une la energía y la masa. La luz se mueve con increíble rapidez, a casi 1.100 millones de kilómetros por hora. Por eso los científicos usan el término C, celeritas en latín, que significa velocidad. Mucho antes del siglo XIX, los científicos habían calculado la velocidad de la luz, pero nadie sabía qué era exactamente. En Inglaterra, un hombre que ya conocemos estaba por hacer una estimación fundamentada. Tras la muerte de Sir Humphrey Davy, Michael Faraday se convirtió en el profesor Faraday, uno de los investigadores más importantes del mundo. A la comunidad científica aún le costaba aceptar que la electricidad y el magnetismo eran dos aspectos del mismo fenómeno que Faraday llamaba electromagnetismo. Pero esta vez tenía una proposición aún más extravagante para su público.
Invisible lines that can emanate from electricity in a wire, from a magnet, or even from the sun. For it is my contention that light itself is just one form of these vibrating lines of electromagnetism.
Por 15 años luchó Faraday para convencer a los escépticos de que la luz era una onda electromagnética, pero le faltaban los cálculos avanzados que sustentaran su idea. A la larga, alguien fue a su rescate. El profesor James Clerk Maxwell creía en las adelantadas ideas de Faraday y tenía la habilidad matemática para demostrarlo. Maxwell y el ya anciano Faraday se volvieron buenos amigos.
James, forgive me. A word of advice. Don't get old.
Michael, how are you?
I'm fine. Memory isn't too good.
Well, I thought you might like to see what I've just published.
Oh, yes. Yes. Splendid.
So your results show that when electricity flows along a wire, what it actually does is create a little bit of magnetism. And as that magnetic charge moves, it creates a little piece of electricity. Electricity and magnetism are interwoven, like a never-ending braid. So it is always pulsing forward.
It's wonderful.
Michael, there's something very crucial in maths. This electricity producing magnetism and magnetism producing electricity can only ever happen at a very particular speed. The equations are very clear about it. They come up with just one number. 670 million miles per hour.
I'm not sure.
It's the speed of light. That is the speed of light. You were right all along. Light is an electromagnetic wave.
Maxwell había demostrado que Faraday tenía razón. La electricidad y el magnetismo son dos aspectos solamente de una unidad más profunda. Una fuerza ahora llamada electromagnetismo que viaja a 1070 millones de kilómetros por hora. En su forma visible no es otra cosa más que la luz misma. Y nada le fascinaba más al joven Einstein que la luz.
We have lectures in half an hour.
Oh, let me think. Professor Weber and his life-draining monologue? Or you, Mozart, and James Clerk Maxwell?
We can't. We'll get a warning.
Our project is too precious to waste time listening to those dullards. Come with me. We'll read Maxwell and think about the electromagnetic theory of light.
Oh, why, my dear little Johnny, how you enchant a lady. She's very pretty.
Yes. But can she soar and dance like our dark souls do?
Maxwell's equations contained an incredible prediction. They said you could never catch up to a beam of light. Even if you were traveling at 670 million miles an hour, you would still see light squiggle away from you at 670 million miles an hour.
Do you see how she stares at that wave?
Yes.
You see how for her it is static?
Yes.
She and the wave are traveling at the same speed. We see the wave moving through the water, but relative to her, it just sits there. So is light like that?
Common sense would say that if you caught up to a light beam, there would be a wave of light just sitting there. Maybe it would be shimmering, a bit of electricity and a bit of magnetism.
So, if she was traveling alongside the light wave, it wouldn't be moving. It would be static. But Maxwell says you can't have static light.
Maybe Maxwell is wrong. Maybe if you catch up to light, it is static, Albert, like a wave next to a boat.
Imagine if I was sitting still and holding a mirror to my face. And the light travels from my face to the mirror, and I see my face.
Yes.
However, if I and the mirror were traveling at the speed of light...
You're going at the same speed as the light leaving your face.
Exactly.
The light never reaches the mirror.
So would I be invisible?
That doesn't make sense.
El joven Einstein comenzaba a darse cuenta de que la luz era diferente a cualquier otro tipo de onda. Einstein estaba por entrar a un universo surreal en el que la energía, la masa y la velocidad de la luz se entretejen en una forma que nadie había sospechado nunca. Pero había un último ingrediente matemático que Einstein necesitaba: el proceso cotidiano de elevar a